Okay, so let's do a review over the property of logarithms. So first, let's look at the basic logarithms. Whenever your base is the same as this number, your answer is 1. So this example here, this is log base 14 of 14 is just 1. Because if you think about it, if I rewrite this is 14 to the first power equals 14. Okay? Log of 1 is always 0. Because if you think about it, base to the power of 0 is 1. Anything to the power of 0 is 1. Okay, so this example, if I rewrote this into, well, the log of 1 is always 0, but if I rewrote this into exponential form, this would be base 3 to the power of 0 is 1. Okay, now let's review the product rule. Whenever you have the product of two things, you can expand it by saying log base b of m plus log base b of n. That is the rule, and this is a example. We're going to condense it. So we'll do base 5, 6 times 7 is 42. Now we're going to expand using the product rule. So I'm going to have log base 2 plus log base 2. Now what can go on both of these?
7 and 9.
Yep, 7 and 9, because 7 times 9 is 63. So that is how we expand using the product rule. Now let's use the quotient rule. The quotient rule says log base b of m divided by n can be written as log base b of m minus log base b of n. So we're going to use the quotient rule to condense this example. This will be log base 4 of 84 divided by 12. And what is that? What's 84 divided by 12? 7, thank you. Log base 4 of 7 is what this condenses to. Now we're going to expand using the quotient rule. So guys, can y'all give me two numbers that will, when you divide it, you get 9? Okay, 27 divided by 3 will give you the 9. And this is how we would rewrite it. This would be log 27 minus log of 3. This is expanded. Now you can have many different answers. You could have also chosen 18 divided by 2. Okay, so there's different ways you can expand this. There's not just one right answer. Okay. So that is a review of product rule and quotient rule. Let's go ahead and move on to the power rule. And guys, we're not doing change of base this unit, so I'm just going to scribble this part out. Okay, so the power rule. When you have your log to the power of n, you can rewrite it as n being the coefficient, log base b of m. That is the power rule. So that means this coefficient can now become the exponent here. So this can be rewritten as log base 3 of 8 squared. And what is 8 squared? So this will just become log base 3 of 64. Now we're going to expand using the power rule. This exponent can come to the front and be the coefficient. So this x minus 1 will be in the front. And then you have log base 2 of 6. And remember, guys, whenever you do not have a base, when the base is not written, that means your base is 10. So on this previous example here, log of 9, it didn't have a base written there, that means this is the common log. Your base is 10. All right, so that is the end of our review. Okay, this was a homework problem. I believe this was number 17 on y'all's homework. So let's expand this. Whenever you have a square root symbol, that's the same thing as, instead of writing the square root, you can write this as 1/2. Okay? The square root of x is the same thing as x to the 1/2. Okay? Now, we're going to use the power rule and put the exponent to the front. So this can now be 1/2 of log base 5 a7 to the b, or times b. Okay, and let's go ahead and expand this even further. These are being multiplied together. So you can write this as 1/2 log base 5 a to the 7 plus log base 5b. And then I'm going to go ahead and do the product rule again. This exponent of 7 can come to the front. So you can write this as 1/2 is still on the outside, but I have 7 log base 5a plus log base 5b. And then finally, we can distribute this 1/2 in. So this will be 7/2 log base 5 of a plus, bring this 1/2 here, 1/2 log base 5b. So this would be your final answer expanded.